Hi everyone, and welcome to this webinar brought to you by the Information Lab. Here at the Information Lab, we dedicate ourselves to helping people make sense of data using Tableau and Alteryx. I'm Ellie, and I'm back with you in this second episode of our series of web training, where we're focused on getting the most value from your geographic data in Tableau. If you're confident in creating maps using explicit latitude-longitude fields and Tableau's internal geocoding engine, as well as knowing your way around the built-in map layers, then you are in the right place to add some more sophistication to your visualization practice. If you aren't confident in those things yet, click the link on the screen to go back a step and join us here when you're ready. Now, this is a more advanced session, and we're going to look at more ways to get our objects onto a map canvas in Tableau. We'll first look at the nature of UK postcode data and the inherent problems in using that data in Tableau. We'll then, of course, look to solve the problem of postcodes using supplementary data and joins. Finally, we'll look to leverage some of the new spatial capabilities in Tableau to deal with alternative coordinate reference systems. If that's a new term to you, stay tuned because I'll give you the background to it when we get there. Now, for all you folks interested in exploring the same data that I'm using, I'll add some links in the description box below this video. Remember to hit pause on the recording at any time so you can follow along if you'd like to. Now, you also need to know that I'm running Tableau Desktop version 2020.1. If you're on a release before 2019.3, working with alternative coordinate reference systems won't be available to you. But hey, this is a great excuse to get IT to upgrade you. Now, without further ado, let's get that value add from your geographic data. In our first episode, we used a dataset containing details of schools across the City of London. And here it is in our dimensions and measures. Here's the data. Now, we use this dataset to figure out what to do if Tableau does not immediately recognize our geographic fields. Here in the raw data, in the measures, I have X and Y rather than latitude and longitude explicitly. But I know that X and Y are denoting that. So to solve this issue, we first allocated the correct geographic role by right-clicking and scrolling to geographic role and making the selection of latitude for Y and longitude for X. So we right-click, go to geographic role, Y is latitude, and repeat that process for X, geographic role, and longitude. To avoid any later confusion, we then renamed those fields to read latitude and longitude. So let's rename this latitude, and X becomes our longitude field. Marvelous. Now we successfully rendered school locations on a map by double-clicking latitude and longitude, and then dragging the object ID field in from the dimensions in order to enact the disaggregation that we need. So drag object ID onto detail. Marvelous. Now, what you'll also notice is that I have generated latitude and longitude fields in the measures part of the data pane. Now, whenever you see that, they are representing placeholders or flags where Tableau is saying, hey, look, I recognize one of your field names, and I think I can generate these locations for you when you bring that field into the view. If we look at the dimensions of the school address details, Tableau is making that assumption based on this postcode field. If we right-click that field and go to geographic role, we can see that postcode is one of the geographic identifiers that Tableau can plot using its internal reference sheet of latitude and longitude values. Now, what I'm going to do is pop into a new worksheet. I'm going to see what happens when I double-click the postcode field to bring that into the view. Now look in the bottom right-hand corner of the screen, errors, and quite a lot of them. So as I did before, I want to look to troubleshoot this by left-clicking on the error message. And I'm going to go to edit locations because I believe that those locations are correct. Okay. Now the top configuration is correct. We're in the United Kingdom. We want UK postcodes, and the postcode field is called postcode. If we move down a step into this lower box, we can get a bit more of an idea of what's going on. If I double click the unrecognized message and then hit this drop down, I can see that Tableau is only able to recognize the front end of the postcode, something known as the outward code. If I type in AL9, you can see that we have the front end AL9, but we're not able to get the second portion of the postcode in. And Tableau is also not able to strip that out of the original data. And we're going to look to a solution on that. But before we do so, we've got a brief interlude now on the joys of the UK postcode. So let's check out how they work. Postcodes are a way for the UK Postal Delivery Service, the Royal Mail, to code the more than 29 million deliverable addresses in the nation. We encode to try to place the 29 million into more manageable groups. The postcode you're looking at here is the Information Lab's London office. In this and all postcodes, we have an outward code and an inward code. And those two elements are split by a blank space, or they should be. Some data sets you may receive will have removed the space between the outward and the inward code, and we'll talk a little bit more about that later in what the implications might be. But back to the outward code, that is what helps to sort the mail into the correct local area. The inward code directs the mail to the correct local delivery office. So as we read from left to right, we're gradually adding more and more granularity, with the eventual full postcode able to direct a delivery person to a particular set of properties representing a very small area in space. So small that we can accept it being represented in point form rather than polygon. But if we go back into Tableau, we can see from the error that Tableau only recognizes the outward code. And again, it isn't able to read that code as part of the full postcode that we have in the data. Now we can solve this element of the challenge quite simply by using a calculated field with a split function. So I'm going to go ahead and just perform that operation in a new worksheet. So all we're going to do is go up to this caret here in the top right of the data pane, hit create calculated field, and I'm going to call this outward code, because that's what we're creating. Well, let's make that a little bigger, perhaps the whole box a little smaller. Now what I want to do in this case is to split off the front end, the outward part of the code. So I'm going to use a split function in Tableau. If I begin typing that, I can get split. I've pressed enter and I get the short sort of cheat notes for how that split function works. If I look over to the right-hand side, I can get more detail for that function. But what we need to do to configure this is to insert first the string, the field that we want to split. Now I can begin typing that in, or I can drag it from the dimensions. So it's the postcode field that we want to pop in there. I'll follow that with a comma. And I now want the delimiter. What is it in that field that will tell Tableau where to split it? In this case, it's the blank space. So I'm going to open parentheses, hit the space bar, closes parentheses off, follow that with a comma. And the final thing that I need to do is insert the token number. So which space do we want Tableau to break this field up on? In this case, it is the first and only blank space. So the token number is going to be 1. We can see that calculation is valid, so we're going to OK that. Great. Now that has successfully run, but we're not finished yet because Tableau doesn't recognize the name of our field. So we're going to go back and help Tableau understand that this is a geographic role. So we'll right-click Outward Code, go to Geographic Role, and select Postcode. Now you'll see the globe icon replace the ABC. So let's double-click that globe icon and see how we go. Okay, brilliant. We've got a map where once there was no map. But we're still left with this quandary over the loss of granularity in the data because we're down to 301 locations here. If you look in the bottom left of the screen, you can see I have 301 marks on the screen. And that's in contrast to the explicit latitude longitude map that had us up at nearly 4,000. And this is a product of using the outward code. It refers to an area, not a specific location. And actually, Tableau knows this. So if I change the mark card using the caret here in the marks, I'm going to change that to map instead of dot. We get an almost complete surface of outward code areas. So this makes slightly more logical sense. Now, I can aggregate the schools to form a thematic map by right-click and dragging on the unique object ID, which I'll do now. I'll drop that onto color, and I'll ask for a count of those unique object IDs. So we create quite a simple thematic map. And this simplifies the view. It shows us the outward code areas that have the greatest and least total numbers of schools within them. But if we want the full granularity of the data, we've lost here. We can't see the density or the distribution of schools within each of those areas. Now, in the next episode, we'll be dealing explicitly with aggregation in detail. So for now, I'm just going to demonstrate that loss of granularity by creating a dual axis map. Now remember, you can hit pause in the video if you'd like to follow along step by step. I'll be leaving some short gaps in my speech as I explain what I'm doing. Now, creating a dual axis map, I'm effectively layering another data set over what I have here already in the view. First, I'll hold down the Control key and drag latitude to duplicate that field in the rows. Hold down Control and drag. Now you can also use longitude. It's the same process. We'll just create 2 columns rather than 2 rows. Ultimately, it doesn't actually matter which one you use because we'll eventually dual axis anyway. So it doesn't matter if we temporarily add another row or another column. I'm going to go for latitude here for no particular reason at all. At the moment, I have 2 maps that are the same, but I want 2 maps that are different. So I'll expand this lower set of marks for latitude. And that allows me to make some adjustments. And this really is where the fun begins. And we have fun. We have to give a massive thank you to the Tableau devs for providing us with the make point function. Because in order for me to bring the precise points for the schools into this dual axis environment, I need to have that location detail contained in 1 column, not 2 fields of latitude and longitude, 1 column that collects those 2 fields into a single geometry, a spatial point. Here's how we do that. We're back to creating a new calculated field by clicking the caret in the top right of the data pane. So let's go ahead and do that. And create a calculated field, and I'm going to call this school locations. Let's make this a little bigger. We need the spatial function make point. And if I begin to type that, we can bring it up and see what elements we need to include to make it work. Here we go. Again, we've got the short help option, and then we've got some of the longer details here. Now at the minute, we want the first variation of make point, where we're going to have a number and a number. The second variation with 3 numbers we'll come back to later. If we look over to the right-hand side, this function is going to return a spatial object. That's what we want. It's going to be constructed from latitude and longitude, which we have. So let's go ahead and fill in these brackets. So we want make point, latitude, and I'll drag that in to the view. And I can also begin typing and select longitude. Let me bring that in. Here we go. So that calculation is valid. We're going to OK this. And you can see now I have a new blue globe indicating school locations. So this has worked so far. What we need to do now is replace what we have in the lower set of marks for latitude with the newly created field, the school's location, along with the object ID, so that we can have a little bit more control over how things are displayed. So let's go ahead and do that. I drag school locations over the top of outward code, and that will replace it. I'm going to get rid of the object ID, which was on color, just by dragging that off. I'm also going to convert this from map to circle. I'm going to change that size a little, and I want object ID. Here we go. I'm also going to change this color just to make things a bit more obvious. And let's perhaps make that slightly smaller again. Okay, and this is coming together nicely. You can see that the only thing left to do is to take that step of layering the school points over the top of the outcode areas. And we do this by right-clicking the duplicated field, that's latitude in my case, and hitting dual axis. So right-click and dual axis. It's a dream come true, because we now have a view of the aggregated and the raw data, illustrating the challenge of the outcode and the loss of granularity. Now, especially if I look at this most southerly area, the entire area receives the color, but the school is sitting up there in the extreme north. And we're fortunate here that the dataset contains both latitude and longitude and postcode, so I can illustrate this quite simply for you. But if you only have postcode data available, you will have to make that call about whether the aggregation is acceptable or not. If you decide that it is not, you're going to need a solution. And a solution that we can enact ourselves is to supplement our data, to find a lookup table where we can use the full postcode to pull back the latitude and longitude data. And luckily in the UK, we have open access to a whole host of cold data sets, including the Office for National Statistics GeoPortal, from which we can download a full UK postcode database, including the latitude and longitude values for each postcode. Now, I've already downloaded the February 2020 dataset. So what I do now is establish a connection between my schools dataset and my postcode directory. So let's pop back into Tableau again. Now, to avoid any confusion or doubt about this method, I'm also going to use a stripped back version of the schools dataset where I've removed all geographic identifiers apart from the postcode. So there really is no way to get the full granularity on the map at this point. Let's add that new data source in. My schools coming in as a text file, a CSV. And here we go, we're going to choose the schools with the postcode only and read those in. What I'm going to do is just make object ID a discrete dimension by right-clicking, hit discrete, and then I'll drag it up to dimensions. As before, notice that we have latitude and longitude generated fields, but we know already that they're coming from postcode, and we know already that this isn't going to work for the granularity that we want. Now let's go back to the data source pane over in the far left. And also over in the far left, we're going to set up a connection to our Office of National Statistics CSV file, a text file edition. So let's select text file. We'll navigate to where my directory is, and we'll read that in. Marvelous. Now what I need to do now is relate these two data sets. And I want my relation to be a join, and I want that join to run based on the postcode field and to return only the postcodes from that left-hand side data set from the school's data set. So I'm going to select a left join to do that based on postcodes from the school file. And also, if we scroll down, this field of PCD postcode from our ONS file. Now you can see that that has run successfully. However, I also know that we sometimes get postcode data where the space between the outward and the inward code is being removed. If that happens, it will cause our join to misfire. But to head that off at the pass, I'm going to write a join calculation that removes any blanks if they exist, and then run the join based on that calculation. We're going to do that in this way. So we're back into the join, the data source for schools. Instead of selecting the postcode, I'm going to go down to create join calculation. And in this case, I don't want to split anything. I want to remove something. When actually in Tableau, what I want to do is replace. So I want to replace any blank spaces with nothing at all. So I'm going to start typing replace. You can see the quick notes. I want to replace a string or something in my string, and the string field is the postcode. Identify what is the substring that I need to replace. In this case, it's going to be a blank space. So we'll open parentheses, hit the space bar, close parentheses, have another column. What I'm replacing this with is nothing. I just want to remove that blank space. So I open and immediately close parentheses, nothing inside that. And then I close my brackets. And we're going to apply that and OK. And to make sure that my join fires correctly, just to cover my bases, I'm going to perform the exact same thing on the right-hand side. Knowing that PCD is the postcode field from my ONS data. Again, I'm going for replace. And in the postcode string, I want to replace any spaces with nothing. And then we're going to apply and OK that. You can see still that the join is working. Now, we've got the real test. Is this going to give us what we want? So we're going to go back into our worksheet for our join. Let me just clean up some of these dimensions. I'm just going to minimize these fields, and we're going to expand up the measures so we can take a look. Again, notice latitude, longitude generated fields. They are coming in from the postcode, and they're not going to work. These lat long fields, they have come in from the ONS postcode directory lookup file, and they're what we're going to use. So we double click latitude, double click longitude. Here's where we get a little suspension build up. Remember that what we're looking for when we put latitude and longitude into the view and disaggregate it using the object ID, what we want is 3887 objects in the view. Here we go, object ID coming in on detail. We've done it. Bottom left, 3887 marks in the view. Let's adjust that size a little bit. Not that much. Smashing, we did it. We're now at the stage of using not only explicit latitude longitude fields, not only Tableau's internal geocoding engine, but also supplementary data to get the results that we want. It's going to be difficult to top what we've just done, but we do have something else to explore in this episode before we finish, and that is our ability to leverage Tableau's new spatial functions with alternative coordinate reference systems. Those are geographic identifiers in our data sets that are X and Y fields, but not latitude and longitude. Another brief interlude coming your way, and this time into coordinate reference systems, where they come from and how we use them. Now, this is a big topic, much more detailed than what I cover here. If you do wish to read some more about this, I cannot recommend enough the blogs of tableau mapping guru Sarah Battersby. Please give that a read, and it's linked in the description box. Let's take a look. Put simply, for the purposes of this sort of short webinar, the Earth is a 3D object. It's almost spherical. It has some lumps and bumps, mountains. When we locate ourselves on that sphere, we use the latitude and longitude degrees, north and south, from -90 to +90 degrees at the poles, east, west, from -180 to +180 degrees at the international dateline. In order to represent the 3D Earth in 2D form on a flat piece of paper or on a computer screen, we need to squash down the 3D object to make it flat. Now, there are an almost infinite number of ways to perform that squashing, and you'll see some on the screen just now. The selection of the squashing method really depends on the mapping purposes. If we wanted to focus on Antarctica, for example, we'd squash our 3D Earth in such a way that Antarctica is the focus, and that any distortion that's been introduced from the squashing procedure is minimized. This squashing procedure will give us not only a different projection or squashing method, but also a different set of identifiers that specify the way the projection should operate and its parameters. And we can think of those new identifiers as our new XY fields. And while the use of latitude and longitude is a standard, universally applicable system, the new coordinate reference system is different for each projection that we have, whether that's our system for Antarctica, as data school consultant Ellie used in this biz, or the system for the United Kingdom. And we're going to have a look at how coordinate reference systems work, specifically for the UK, so that we can move along with our schools data. Our UK-focused coordinate reference system is called British National Grid. As the name suggests, it's a grid-based system that helps us to identify location. The easting is the x coordinate running west-east, and the northing is the y coordinate running south-north. For British National Grid, we read along the easting first, then up the northing. And if we want to identify the red square in this example, the general location at a 1 kilometer resolution is 6450. If we break that larger grid into smaller grids, as is being done here, we can call the red square 64650-4, and that gives us a 100-meter grid square. Now, the more we split each grid into subsequently smaller grids, the greater the spatial resolution we get, to the extent that we can have 6 figures in each of the eastings and northings field, and that will give us a location at a 1 meter resolution. Reflecting back on the schools data set we have, you can see here we have 6 figures for each of the fields, eastings and northings. So it would be possible to locate the schools to a very high level of granularity. The challenge now is making Tableau understand this coordinate reference system because its own system is not the same. Tableau natively recognizes latitude and longitude because it is using something called the Web Mercator projection. That's the squashing methodology that Tableau uses by default. We therefore need to tell Tableau that our XY fields are in a different form to that. And we then need to help Tableau understand how to convert the XY fields, the eastings and northings, into collected latitude and longitude points, which we can then natively plot. Now, this operation is a huge deal. And it's another huge thank you to the people at Tableau who have made this possible. Now let's work through the details. Well, like I did before, I'm going to use a schools data set where I've removed all the geographic identifiers with the exception of the eastings and northings. No cheating, no hustle, no tricks. Let's add this new data set in. Again, it's a CSV, so I'll go for text file. And I'm going to navigate to schools, BNG only, British National Grid only. So let's open that up. I'm going to pop back into this worksheet. And again, I'm going to change by right-clicking Object ID. Let's change that to discrete. Then I'm going to drag that up into dimensions. Now notice here, we don't even have a generated latitude and longitude. At the minute, no geographic identifiers. Now the small caveat to this method, before we really get into it, is that we need our data source to be live when we perform this reprojection operation. But once we've performed that calculation, we can then do the extraction. But again, when you perform this calculation, you need to have a live data source. All right, all set. Now, as I just mentioned, we're going to collect the equivalent latitude and longitude values for the eastings and northings into a single field that we can plot. So we are back with the make point function. So let's create a new calculated field, again, using this drop down in the top right of the data pane. Let's go for calculated field. And we're going to call this schools. I'm just going to tag on that this is British National Grid, BNG. Let's make this bigger. Again, if I start to type make point, I can bring that in. Now this time around, we're not looking at the make point number. We're looking at make point number. If we look at the expanded instructions on the right-hand side, we are looking for Tableau to create a spatial object when constructed from an X coordinate, an easting, and a Y coordinate, a northing. So imagine the easting is the X-axis and the northing as the Y-axis, and then something called an SRID, which we'll come to. So let's start dragging some fields in. The first object, the easting, separate that with a comma, and then drag the northing into this calculation box. And the final thing that we need to do is add the magic. That's the special ingredient that tells Tableau what system the original data are in. That is the SRID. And that's simply a numerical code that represents the name of our alternative coordinate reference system. In this case, we want the code that corresponds to British National Grid. Now, I know that that is 27700. And I know that because I've used this searchable website, which is called spatialreference.org. Simple address, but again, that's linked in the description for you. Notice that the notation here is EPSG, but it's referring to the same thing as SRID. Now, if I search British National Grid, the most commonly accepted and used projection for British National Grid is this 27700. So that's the SRID that I use. Let's pop back into Tableau. And that calculated field is now complete. It's valid. Let's apply. We can see that we've now got the blue globe, so it looks like it should have worked. What we need to do is figure out if it has worked. So we're going to double click schools BNG. It looks right. It looks right. Notice so far that we're plotting a single object in the bottom left. It's telling me 1 mark. and that's the collected geometry for the entire data set. And until we add some granularity into the view, Tableau won't tell us that we've got any more marks. So again, we want to grab the object ID, put that onto detail. We've done it. Again, we've done it. Bottom left, 3887 marks in the view, 3887 schools in our data set. And because I've put the object ID in, I'm now able to interrogate and interact with each of those dots individually. Now, I don't know about you, I'm blown away. Like, this is the dream. It's become a reality. Without latitude, longitude, without a specified geographic role, we've got objects onto our map canvas in Tableau. That is a beautiful thing. It's been intense. It's been pretty involved. It's been quite advanced. And well done for sticking with it. Although it has been advanced, we're still really at the stage of answering the contextual "where are the objects" questions. And of course, we want to build on that and go further. Next time, we will go further and we'll look at how we aggregate spatial data effectively. Until then, keep exploring and feel free to reach out to us here at the Information Lab for solutions to your data challenges. Stay safe, and I'll see you all next time.